All right, now with that, we're done with step 8. All we got to do is graph this in Desmos. And I want to show you how to make a graph as beautiful as this is, with everything labeled and all. You see how I've got my slant asymptote labeled, I've got my vertical asymptotes labeled, and all of that good stuff. So let me pull up Desmos really quickly. So here we are in Desmos, and you'll remember I've been using it to kind of do some calculations, and it's graphed some dots for me, but I don't really need those dots. So the way to turn those off is to to click on the purple thing right there, turns off the dots. Black thing right there turns off the dots. If I scroll down, if I click on that, it just turns them off. And I know I'm trying to graph this function f of x, and I want to make it black. So I'm going to let my mouse, I'm holding down on the left mouse button, and once I hold down on it long enough, it'll let me choose my style and color. So I'm going to choose black here. Okay, and now to change my windows, I want to go from -3 to 3. Oop. So I'm just clicking down here on the x-axis. So -3 to 3. I'm leaving in grids and all that good stuff. Arrows would just put arrows at the end of your lovely x and y axis, so they're not necessary. The y axis, well, if you look at the one I have on the page, and you can see it right here, like we're not seeing a lot of what we said we would see. See, that's where graphing fails you. This is one of the reasons we do analytical methods. Because if you just throw this into a calculator or you throw it into Desmos, it'll look like this. And you're like, okay, I'm done. But you're not, right? There's more going on to this graph, and we couldn't see it. But you can kind of see it if you look at your f values down here. These are the f of x values. Do you see how high and low those are for the square root of 3? Those are in the 20s. So what I need to do is I need to change my y scale. And I'm going to go -50 to 50. This is where analytical methods are helpful because they can show us what's going on past the limits of our window that we're looking at on our screen. All right, so there's the basic graph right there. All right, but that's not good enough, right? We want to label everything that we found and all of that good stuff. Okay, so we can start with let's start with the vertical asymptotes and horizontal asymptotes and the slant asymptotes, since were just doing that. Now, if you want to hide these things so you don't want to see these calculations because they're kind of big and they're in the way, what you can do is click on the little plus sign and click folder. And you can say, let's see, test interval calculations or something like that. And then I can take this, I'm gonna move my arrow or my cursor down here, so see how it turns into that four-sided arrow? And then I just click and drag. Whoop. I did it wrong. Hold on. Where's the folder? There it is. So click and drag. Click. Drag. Oh, there it was. Shoot, it was in there. And I pulled it out. Do you see how it's in? When it's in there, you'll see a little line on the side. Here, I'm clicking and dragging it over. What I'm doing is I'm dragging it to the right. See that little line? That means that when I click on that little arrow, it'll get hidden inside that folder, so I don't have to look at it all the time. So for this one up here, I'm going to click and drag it down. So I clicked and I'm dragging it down and to the right. And then I let go, and see that vertical line? It's now inside this folder. So if I click on that arrow, then all those calculations disappear, and then I don't have to live with all that garbage. Okay, so now what are my asymptotes? I have x equals 1. Enter. I have x equals -1. Enter. And then I had y equals 10x. Oop, 10x. There we go. All right, well, I don't like the color choices at all. So I'm going to click on this and I'm going to hold it down. I hold down the left mouse button and I'm going to say I want this to be a dashed line and I want it to be orange. And I'm going to do the same on this one. Click on this red one, dashed line orange. Click on this blue one. I make it dashed and I made it red. There they are. Now I've got all my asymptotes. Okay, that's lovely. Now what about all of my labels? Because I want to label those. As a matter of fact, I'm going to make a new folder right here. So I'm going to click up on this folder. I'm going to click folder. I'm going to call it asymptotes. And then I'm just going to click down here, right, drag, click, and then drag, and then click, and then drag. And now that'll all be hidden too if I want it to be, right? Makes it look cleaner. Okay, now I want to get some labels here. So I have labels kind of hovering down here at the bottom of these lines. The way I did that was I made a point that I knew would be on that line, like let's say -1, -50. So -1, comma, -50. All right, oh, I'm going to drag it over so it's underneath that folder. I'm going to click on it. I'm going to make it orange so it matches the line, and I'm going to turn it off so that it's hidden. So, oh, sorry, I don't turn it off there. I turn it off here. Click out there. So you're thinking, well, how did that help? Well, if I click on label, it's going to label the point. I don't want it to label the point. I want it to label x equals -1. That was the equation of the line. Now, I don't like the fact that it's putting it in there, so because it makes it hard to read. So if I click on the little wrench, I can make decisions about how I want this to look. So for example, I want it to be over to the right. There, that makes it a little bit better. I want the font to be a little larger, or I want the font to be smaller, or whatever. And there you go. It gives you just a few choices there. I'm going to do the same thing. And actually, if you click up on this point, -150, and I click enter, it automatically assumes, see that vertical line, that I still want to be in this folder. So I'm going to do the same thing with 1 and 50. 1 and -50, sorry. I'm going to put it down at the bottom. It's your choice where you put it, but I'm going to put it down there. I'm going to say x equals 1 as my label. I'm going to click off of this and make it orange, but then I'm also going to turn it off. And then when I turn it off, it makes it go onto the line, so I'm going to click over here and make it go to the right. Last but not least, I want to label my slant asymptote. So I'm labeling it kind of over here at like 2 and some change. So 2, 20, or here, 2, 20. Yeah, that's a pretty good label spot. So I'm going to click label, turn off the point itself. I'm going to say y equals 10x. And then you can play around if you want it to be maybe below that spot or something like that. All right, so now all our asymptotes are labeled. And it just occurred to me I should probably save this graph. So I'm going to, if I click up on that name, I'm just going to name it Math 151 4.4 Example 1. Now, if you're doing this for your worksheet, you could actually number which one it is in the worksheet, and you can share it over here with Share Graph with your professor or whomever, right? You can copy the link and send it to them. You can print, right? This is where you go to print the graph, and so on. Just as a warning, it wants to print all the stuff you typed in as well, so make sure you only print page 1 because that's all you need. All right, we'll show that a little bit more in a second. But we have one more thing to do, which is to label our critical points. So we had critical points. Oh, I'm going to make a folder for them because it's just prettier. So I'm going to call it critical point values, right? First and second order critical values. If I press enter, it automatically is embedding whatever I want to type underneath that folder heading. So I'm going to say, all right, I want the point, and it was negative SQRT 3. I don't know why I have parentheses in there, comma, and then it was f of negative square root 3, right? I don't need to actually find the function value. It'll find it for me. It's right there, right? And actually, if you click on the graph, you can actually get them to show them to you, right? They're right there, right? Negative 1.732 and so on. But the problem with that is that if you click off of them, they disappear again. I wanted to actually have them in there. So I put these in blue. I'm going to label it. Instead of that giant label, I'm going to label it like critical value or critical point or something like that. All right, let's do it again. So if I click up here on the parentheses and I click enter, after the parentheses I should say, and then I'm going to do another one, SQRT of 3, move my arrow over, comma, f of SQRT of 3. I've got another point. I'm going to click on it and make it blue. There we go. And I'm going to label it, and then I'm going to call it crit point. Now technically, actually, I should be a little bit more precise about this. I didn't do a good job of this because this is a local max and this is a local min. I should change those in the notes as well, and I will. So that was the local min, that's the local max that we found. And then the inflection point we found is 0, 0, right? Or if you like, it's 0 f of 0, if you want me to prove that it works out that way, which it does. I'm going to make that green, and I'm going to label it the inflection point. So I'm going to click on that and say inflection point. And there we have it. So I'm going to click save, so it saves my beautiful graph. And you can hide all those calculations by making that arrow disappear. Right, there they are, now they're gone. And if I click over here, you can see the whole graph in all of its glory. So I have my function and all that good stuff. So I'm going to click share graph, and I could email my professor this, right? I could export the image if I want to put it somewhere like in a Word document, or I could embed it in a web page if I so desired. But generally your professor is going to want you to email it to them with that copy link, or to click print and print it out. Again, be careful that you only print it the first page. I imagine your professor doesn't want to see the next page unless they specifically ask you, let me see the next page with all the calculations, in which case you would want to open up all of those hidden folders so that way everything is seen in the print. And that's how to work with Desmos. Or at least the beginnings of how to work with Desmos.